bit on how to go through the extra credit. So here's a bunch of instructions, and they're showing that, yeah, depending on what computer you're using, you install it in a different way. So if you're working on a Windows PC and you want to do this, this is totally optional, but I'm walking you through it just so you can see, because these are important bioinformatics tools. What you need to do first is you need to install everything. So first step for Windows, you're going to install Windows Subsystem for Linux, WSL. You can go to that link. That is the Microsoft approved download page, Microsoft.com, that will get that installed. It's free, and it runs on your Windows PC. Once you have that installed, you'll then need to go through and there may be problems that we have to fix, and I don't know. I can sometimes help, but I'm not a great pan computer tech support guy. Yeah, but I try. Yeah. Anyway, once you have your virtual machine running, then you can run these commands. So sudo, and remember, this is the sudo is like the authority elevating command. It's like, no, I mean it. Actually do this. It's apt-get is going to be the one that is going to be built into WSL. If you load Ubuntu Linux, Ubuntu, apt-get, and then apt-get program can do a couple of things. It can install or uninstall. In this case, you're going to tell apt-get to install, and then it's going to say, well, what do you want me to install? And you're going to say, I want you to install the SRA toolkit. And so, bam, you're going to do that. And that's going to give you a whole bunch of NCBI tools, basically, that you need in order to do this. And then you can do the same thing for Bowtie2 and SAMtools and BCF tools. All right, if you're running on a Mac, you're first going to have to install Homebrew and copy this entire thing all the way down to the quotation mark. Copy that and paste that in your terminal, and then it will run and it will install this thing. If you have problems like mine, it said has a problem that my thing is not in the path, then we have to go and Google how we export particular directories to our path. The path is just a list of things that the computer understands and it knows where to look. And so to run a program, you tell it the name of the program. You can always run it if you can tell it exactly where to look, but because that's annoying to keep track of it, we would tend to install it this way and just add different things to our path. And so now we can say path, hey, go check in this folder, whatever it is, /opt/homebrew/bin. You'll find some good stuff there. So there are ways to do that, and we have to look those up online, because I never remember which language I'm typing in and which way you do that. Okay, and then for Mac, if you're able to install this thing, which is the Homebrew kit, the command that runs it is called brew, and like these other things, it can install or uninstall. There are other ways to install stuff. It's just that there are no other ways that are easier. Like Miniconda can install, or Bioconda can install. There's a bunch of ways to do this. Ruby is an old way they can install. Yeah, what you need is a working installation, and this is the annoying part where you're going through. So go through, you do all those things. That's great. Okay, if you want to check that you've installed your things, so each of these, if it has a little hashtag in front of it, that means this is something that is basically commented out. You can ignore this. If you type it in your computer will ignore it. So no big deal. This thing below it is an actual command. So if you type bowtie2 -- help and you have a bowtie2 installed, then this will actually run. I need to troubleshoot a little more. This is not my normal work computer. This is a different one. So it is not set up for anything, and it takes a little while to set up. Anyway, once you get down here, so after you've got all of this, and if you want to play around with Linux, that's a nice place to do it. then you can, here we go. So it's saying cd to swiggle. That's your home directory. Yeah, you remember that? Yeah. Then it's saying in that home directory, let's make a new folder, and we're going to call it read depth, the folder. And I'm not going to put a space in there because I'm not a glutton for punishment. And so after we make that folder, bam, we just copy this, drop it in, hit return, or type it, hit return, and it'll do it. Then we can go into the folder called read depth, and that's cd read depth. Great. Now let's explain some of these commands. So this one is going to open up a program called fastqdump. And fastqdump is part of that SRA toolkit that we installed up here or here. Yeah. You notice one of them has a dash and the other one doesn't. You got to type it exactly like that or else it will not install. So fastqdump will go out and it will take these giant files and it will just put them onto your computer. It'll make a copy of them and transfer them from servers in foreign countries. Isn't that cool? So fastqdump needs some options. So the split 3 will split your reads into the 0.1s and the 0.2s. If you have a paired end data set, you have to do this. The third choice is if it's not a paired end data set, then it'll just put them all in one pile. If you do split 3, split dash 3, it's going to work. And so that's a good thing to do just in general. This is going to try to download FASTQ files instead of FASTA files. FASTA files are just the sequence. FASTQ has an extra line. And so for each nucleotide or amino acid of the sequence, it has a quality score that tells you how certain this particular call was based on the experiment. And that doubles the size of the thing you're downloading, and we also are not going to use that for the little bit of read depth mapping that we're doing. So let's download something that's half as big. So let's only download the FASTA part of the FASTQ file, which is quality plus FASTA. And so --FASTA, put the FASTA flag on, and now you're just going to download the FASTA stuff that you need. Read IDs flag is going to download a particular SRA dataset. So there are 3 different repositories that have these. So there's the one in the USA, and so those all start with an S, like SRA is the USA's version of a sequence read archive, and it was the first one. Then there's going to be an ERA for the European version, and there's going to be a DRA for the Japanese version, and it's from the DBJ, the database of Japan, which is their own thing. You can find these all mirrored almost exactly on every one of these servers. So each of those 3 servers has a copy of everything on each of the other servers. But yeah, so this tells us we are actually going out and we're getting some originally Japanese uploaded data, which that's pretty cool, right? And those are the only 3 big servers that are all connected to each other. There are other smaller ones. I think China have some smaller ones, but yeah, you wouldn't need those. Those wouldn't be available. So that's what those commands are going to do. And then, okay, so you're going to download this file, and if you click the link, it'll actually download the file. Then you have to move it using an MV command or a CP to copy it from wherever it lands on your computer, and I have no idea where you download your files to. And you have to move it over to the Linux drive. So that's going to be moving it through C drive if you're on a PC, probably, if it's set up that way. Or in my case, I'll just go to the downloads folder and move it over because, yeah, it's a Mac. All right. And so now let's go into, so we can move it from wherever it is. If you go to the folder where it is, you say, just put this command in. You just copy it and paste it, and it will move msgurnis.txt, which you just downloaded, into home directory /read depth file or folder /dot, which means, yeah, put it there. That's what the dot is. Okay. And then we can remove all the things that we're going to make. So if you're running this the first time, skip this command. If you're running it the second time, this command will clear out all the stuff from the last run. So you can remove reference FA, map.sam. Remove, you can just put a whole bunch of things and it will remove all of them in a row. Don't need commas, just put a space between. Yeah. Then we can see what's there with an ls-la command. So we'll see the size of everything that's there and what is there. When you run these commands, your computer may appear to just like sit there and do nothing for half an hour for each command. That's because you have, or we all have, bad internet connections, but also because this is a giant file. You're downloading, I don't know, it's like 4 gigabytes in each one of these files. So yeah, it takes a little while to download it all the way from Japan. But yeah, just that command does it for you. So that's a cleanup command. Then let's look around. And then there's a cat command. So what we're going to do is we're going to take, since this virus, Misgernus virus, occurs in multiple data sets, we're going to put our data sets together because that is an easy way to do this. There are other ways you can do this that are, less silly, honestly, but this is fine. So cat will take 2 files and it'll stick them after each other in the same file. So we'll take the first file, take the second file, and put it right at the end of the first file. So they're one big happy file. And so you cat any number of things, all the things you want to stick together, and you put a little greater than, which shows you where they're going, and then you give it the name of a new file, and it'll make this new file, and it'll fill it with all of this, then all of this. And so we'll put all our 0.1s into that, and we'll put all our 0.2s into this. There you go. All right. Then let's take misgernus.txt, and so for some later things, we're going to need this to have a particular extension. That's the thing after the dot. And so the extension that we're going to need is .fa, which is a FASTA. Yeah, they abbreviated it as FA extension. So we'll just move the name. We're basically changing the name from misgernus.txt to misgernus.fa. All right, now let's start with the actual programs. You're going to use Bowtie2 build, which is one of the things you downloaded with Bowtie2, and Bowtie2 build will get misgernus.fa ready for action. So what Bowtie does is it gets a map of the thing you want, and it takes all the little tiny reads from the SRA, and we'll see if they align to them anywhere on the map, reverse complement or normal, and it will try to align every single one of them. Does a great job. It's really fast because it's going through gigabytes of data, and imagine doing, 6 million blasts. Imagine how long that would take. Bowtie2 will take, 15 minutes, maybe 10 minutes, maybe 5 minutes, but it's a whole lot faster than you could ever run that many blasts, I tell you that. But that's what it's doing. It's a little local alignment thing, and it's finding local alignments between individual reads and the reference. All right, so and then we're going to turn the SAM file into a BAM file, and that's just the thing we need to do because at the next step we need that. So the program we're going to use is SAMtools, so we just type SAMtools space, and then SAMtools has several littler programs inside it. One of those is the SAMtools view program. So we do SAMtools space view, so now it's like, SAMtools is like, okay, I'm going to boot up the view part, which will show us what's in these files. And the flag -bs says this is going to be the input file, and it's sort of regular, not zipped, and it's a SAM file. That's what the capital S is. And then the greater than means we're going to mapped.bam. And so, yeah, it's going to take everything in the SAM file, change the format to a BAM file, and put it in the BAM file. Why do we need that? Because later on we have to do things, and it has to be done with a BAM file, not a SAM file. So there you go. There you go. Argue with the people that made this, not me. Yeah. Next thing SAMtools can do is it can sort all those little reads. So Bowtie2 took only the things that matched, and it put those into a file called map.sam. Oh, and in Bowtie2, you say -x, and so you say this is your reference. -1, these are your 0.1s, and so we called it m1.fa. -2, those are your 0.2s, and this m2.fa is what we named it right up here with the cat command. So yeah, that'll run, and then the output is going to be in SAM format, so -s, which is going to be map.sam. So yeah, that's what the whole thing means. Then we have SAM tools, and we're going to open up the depth calculating part of that. And this is the thing that we actually wanted to do, but we had to do all these steps to get to this spot. And so this will give us our read depth. And so SAM tools depth -a. So this is going to be our input file, which is mapped.sorted.bam, which we made right up here after we sorted them. And then we're going to go to a file called misgernus.coverage, which is going to be a little map of our coverage. And you can then look at it. So one command you can do is to type the word more, M-O-R-E, space, misgernus.coverage, once it exists. And it'll just start spitting up word salad like this, and just keep hitting space. And it'll go down through the entire thing, but this is what you will see. All whatever it is, like 15,000 bases of it. So this is the form, this is the virus that it matched. This is the position, so position 1, and then this column is the read depth. You can actually just copy all of this right from the output, right on your screen, and you can paste it into an Excel file, and it's perfect. You can read it that way. Yeah, I have another program that I use to pull it out, but yeah. You don't need to do things the way that I do them, because there's a lot of ways to do things. So there you go. That's kind of what the commands are. That's how the Linux works. And basically, once you can make this misgernus file, this is like the test that everything's working, then I can give you a different one, and you can start to actually do it. And the next one is for extra credit. There you go. All right. Thanks a lot.